Okay, good. We're all set. Oh, boy. Let's see. I know that the time to end is 5, but it's whether it's 5 a.m. or p.m. Do you remember? We could stay here till 5 a.m. and have so much fun, huh? Oh, that would be great. I would miss my flight, but that would be okay. I think there was one kind of, we had a good Q&A going over here, but I think there was one more question that you had. Oh, here we go. Oh, you got 2 mics. You can choose which one you want.
Right, so I told you that we are already following the microservices architecture, and we have faced a couple of problems. And I made
Oh,
a list
yes.
right. So I've made a list of those problems, and it all boils down to 2 things.
Uh-huh.
One is related to service identification, which you've already spoken about.
Yeah.
And the second is data volume.
Data.
Data volume.
Oh, yes. Yep. Now, data volume as a problem, in what context?
Just the sheer amount of data.
Oh.
We've got billions. So.
Yes. Okay. Good. So yes, I did talk about the service identification, which is I'm so happy that you validated my experience that this is in fact a big challenge. And so we have some ideas on that. I'm going to show you how to address the data volume pieces as well in a couple of ways. And so I'm going to hold off on the data volume though, because hopefully we'll get a chance to talk about data and the data volume pieces. And yeah, actually, that's a good part that I want to talk about. So yeah, okay, perfect. I can address those. Oh yes, so let's finish up messaging and get on to gRPC because I did want to talk about traceability and scalability aspects as well within microservices. Those were 2 of the other kind of concerns, and I want to kind of address how to do that traceability piece, and we haven't gotten there yet. But there's one last thing that I'm really excited about with microservices in terms of leveraging messaging as a possibility for inter-service communication. Do you remember that the customer demographics had 2,000 messages a second coming in, and the customer wish list had 5, which meant, of course, we needed 2 instances of the demographics and 5 of wish list. And we saw that this didn't work really well with inter-service calls. However, when I use messaging, I have what's called micro-level scalability within my own microservice, which means that chances are, I'd have to tune it, but chances are I still only need 2 instances here. And let me show you how that works. What I'm going to do is this. Does everybody see this customer demographics? Which one am I going to open? Oh, yeah. You see this customer demographics service right here? What I'm going to do is I'm going to open the hood on that. I'm going to open that up. Okay, so watch this. So that's the customer demographics service right here. And what we have is an API access facade class. This is a single class that actually handles all of the RESTful endpoints. Now, it's a facade in the sense that the method names here have all of the path statements and the get, put, post, patch, delete kind of verbs in REST. But these methods right here are empty. The only thing they do singly is invoke one of your classes here to actually do the functionality. And here's the really important part about this kind of templating style. If, in order to place, as a matter of fact, let's use a real example, post a comment. All right, what do I need to do to post a comment? I need to check for bad words, I need to check for grammar abuse, and I need to check for context. 3 things. What you don't do in this class right here, which exposes the RESTful endpoint, which has a method, is to say, invoke the grammar, or invoke the bad word checker, invoke the grammar checker, invoke the context checker. That's micro orchestration. In other words, that's a driver pattern to say, do these 3 things. No. No, no, no. What you do in that facade class right here, in this API access facade, is instead you would have the method which exposes the RESTful endpoint, and then in that method right there, you would say place or post comment. And it would go to this module, this class right here, which would say, Oh, to post a comment, I need to check for bad words. I need to check for grammar abuse. I need to see. You see that driver orchestration, all the steps involved, is in the actual classes here, not in the facade. And I'll tell you why that's so important. Because notice that this is a separation of concerns. Kind of what we get here with this kind of template design is something called protocol agnostic processing. The functionality of my microservice is in these blue classes right here. They know nothing about REST or JSON or XML or SOAP or gRPC. They're processing agnostic. Now, watch this. This is so cool. This API facade, here's that get customer info, handles all of the RESTful endpoints that are happening. I want to do a get name. So what I do is I have two other classes. I have a supervisor and a consumer. Right here, this is just the same kind of class. It's an API that listens on queues. It instantiates the same classes that the API coming from REST is actually instantiating. So now I have my request queue and my reply queue for get name. And as a matter of fact, here's another endpoint. So somebody asked a question about how many queues. Where was that? Somebody says, oh yes, there you are. So now I get all excited because now I get to answer multiple questions here. And so here's the get name queues. There's two of them. It's a channel, but it has a request and a reply queue. And now, let's say that I have a zip code. I need to get a mail code or a zip code, an area code kind of thing. That's a separate kind of contract. It's going to have separate queues going to a separate API facade, which is managed by a supervisor. So you can see if I've got 3 inter-service kind of calls that I need to make, I've got 2 choices. I can do 1 queue per service, and that's called a command pattern because what I have to pass into that message is what the request is that I want to do. Now that does simplify the ecosystem, but it assumes that there's a nice even distribution of the types of requests. Because if I've got, think about this, if I get 45 get name requests instantaneously, and I get 2 zip codes, I've got to process 45 messages before I get to 2 zip code requests. Those are going to go slower. My preference, and the trade-off here is the fact that I'm going to make my infrastructure more complex. My preference is not to use the command pattern because of that, but rather every endpoint request has its own request and reply queues. Because think about this. If I get 45 get name requests and I get 2 zip code requests, those 2 are being processed at the same time. In other words, zip code has the same SLA as get name. You see that? What would happen if I combined all those in a single queue? If the distribution's kind of even, it doesn't matter much, but rarely is the distribution even. And so I prefer, so when we talk about the number of queues, every endpoint would have a corresponding. Now, if it's just a, I got to let you know about this, then there's no reply queue. That's totally async, and it would just be an input queue. There would be no, or a request queue. There would be no reply queue. However, in this case, every endpoint would have its own queue. Request, reply, request, reply. And by the way, here's a tip. Don't use inbound, outbound, or in, out, because it depends on your perspective. What's in for me is out for you. What's out for you is in for me. And it gets really confusing of, well, what's our perspective here? And that's why I make a request and I get a response. And so I sometimes call this the response queue or the reply queue. Okay, now, here is such a cool thing. Do you remember yesterday, for those of you, how many here were here yesterday? Quite a few. Did you go to my reactive talk? Woohoo! All right, now we get to see this stuff applied. Because, do you remember the reactive patterns 1? I talked about the consumer supervisor pattern. That is it right here. There's the supervisor that's listening on this get name. So I only have 2 instances of this microservice, but I am getting inundated with get name requests. While I'm processing 1,000 get customer info requests, I can process hundreds of get name requests at the same time. Why? The consumer supervisor pattern, because this supervisor here is a class. And what it does is it listens on this reply queue saying, by the way, ooh, I just got a bunch of messages, 10 requests for get name. And watch this. Because of that supervisor consumer expanding we saw yesterday, I spin up 10 of those consumers, those APIs. And now I'm processing 10 concurrent get name requests while I'm processing 1,000 get name requests, or the 1,000 RESTful requests at the same time. You see, these are going here, these are going over here. And once I finish up, there's no one else saying get name, and now I can spin those back down. That consumer supervisor pattern we saw. I noticed there were some hands that didn't attend that yesterday's talk. So that consumer supervisor is right here. So what I did, let me get that referential integrity back. So what I did was this. So basically, I'm going to take this supervisor and that API, so that's on the get name, and I'm going to explode that out. I'm going to expand it. And so this is a zoomed view of that API right here, the event consumer, and then that supervisor. Now what the supervisor's doing is this. Every second it wakes up and it says, how many messages are on the queue? And all of a sudden there's all the get names. Boom, we just got a burst of get name requests from everybody. I don't even know from who or from whom. Anyways, so now what I do is this. Oh dear, here I determine the customer's needed. Depth by depth, in other words, the number of messages divided by, usually I do the number of instances. Every instance of a microservice can get the information about how many of me are out there, because that information is available in Zookeeper and Console, and I usually just kind of keep that cached. You know, I have an asynchronous thread that keeps running and checking with Zookeeper about every minute and saying, hey, how many of Mark are out there? How many of Mark are out there? And I can check with Console or Zookeeper or Doozer, whatever my registry is, Kubernetes. So that's what I use that number. If there's 2 demographic services, I don't want to take all those messages because each instance is doing this. And so do you see, that's a programmatic rule that I can vary. If I have 10 instances, then all 10 of us are doing this exact same algorithm at the exact same time. Let's divide everything by 10 so that each of us only have a few. And then, once I have that, I apply any sort of constraint I have. Database connections, threads, and those sort of things, which I can also get programmatically. We saw this in that reactive pattern. And now, watch this. I spin up those event consumers. Boop, 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 boop. And these, by the way, I know we had a conversation at the after reactive patterns 1 about, well, isn't that expensive to spin these up? No, it's milliseconds, and sometimes less than a millisecond to spin these up. They spin up very quickly. You know, again, it has to be that black shirt with the 2 words, it depends on it. Depends what you're doing. In this case, this is just an API. There's no resources whatsoever. That's probably microseconds to instantiate another consumer and grab a channel. Probably microseconds. Well, if I'm grabbing a channel, probably millisecond. Okay, anyways, and then, watch this. It processes all those get name at the same exact time. And now I wake up after a second, I check and say, oh, I only need 1 now. That was that accordion we were playing really, really fast. So yesterday we saw this reactive pattern, and now we're actually seeing it applied in a microservice. I love this pattern of architecture. So anyways, I want to go backwards just 1, because I want to show you, again, our context. There it is. That each endpoint I would leverage the consumer supervisor for. Oh, and by the way, for 1 second, or actually that's a little more than 1 second. For those of you who weren't in my session and you want to see that demo and you also want to see the actual code, you can go to my GitHub repo. It's WMR513, this is in GitHub, WMR513/reactive, all lowercase. And so, so for those of you who weren't in the reactive talk, can actually take a look at the source code exactly for this. And I've got a directory on the GitHub repo called demo, and it's called supervisor, and that's the directory as well. And there's C# code out there as well that I have. But the point is that you can actually get the code that actually runs this to actually see. It's just 1 page of code. It really is. So WMR, William Mark Richards, WMR513/reactive. Okay. Hey, it's your question.
Yeah. While considering the microservices, what are the hardware requirements that do we need to consider before actually architecting all those services?
Oh boy, is that a tangent.
Because I
No,
can-
it's a good question. Fallacy number 7 of the 8 fallacies of distributed computing. Fallacy number 7, transport cost is 0. I know every fallacy there is of those 8. This would be something to Google, by the way, the 8 fallacies of distributed computing, or just type in fallacies, and you get to Wikipedia, which shows the 8. Number 7 is transport cost is 0. It's an assumption that we make. It's a very good question, and this is probably a good time to actually raise this question, as a matter of fact. So it's not quite a tangent. It's a very relevant tangent. Transport cost is 0. You know, most people interpret that fallacy of distributed computing to mean latency. No, because that was fallacy number 3. Fallacy number 1 is latency is 0. Fallacy number 7 happens to be the transport cost is 0. In other words, well, just make a messaging call. Just make a RESTful call. Now I need licensing fees because I have to cluster RabbitMQ, which is going to require a virtual machine that sits on a piece of hardware. I need to make a RESTful call. That's going to require a load balancer and extra switches. This is what's called transport cost. And the fallacy of distributed computing, which is what we're in, is the fact that we make assumptions as architects and developers that this is all free. And in fact, it's not. Hardware costs do increase because now we have to add a gateway, we have to add an API, we have to have a load balancer, now we have to have message brokers. And as we talked about, multiple clusters of RabbitMQ. It's not just one. So when you're looking at licensing, assume about 12. That's what I usually advise most of my customers. Assume about 12 clusters. And each of those clusters may contain multiple instances. Of course it does. So this is a good metric for planning purposes. You may only use 6 right now. But, you know, and again, it depends on the number of services and how complex it is. But that's all licensing cost. And that's going to require hardware. Exactly. If we're up in the cloud, chances are our contracts may have to change. Yeah, very good question, because as we start, as a matter of fact, we haven't gotten started with gRPC and the costs there, or caching and the costs. And so yes, this is what's called transport cost. Yeah, and it's 0. And we got one